So once again, welcome to another session of circuit analysis. We are going to proceed from where we left from, and last time we were dealing with the CR circuits, transient CR circuits, and we dealt with the charging and discharging of the capacitor. This time we are going to be tackling about the LR circuits, where L stands for the inductor and R for the resistance of the circuit. So first, basically, we have to understand how the circuit is drawn, so that we are able to analyze our analysis from the diagram. So the first time is to draw the diagram, understand how the diagram is. So the diagram is drawn like this. So this is L, this is R, and this is the V of S. So this is basically how the diagrams looks like. So from Kirchhoff's voltage law, then the Vs is supposed to be VL plus VR. And we know that VL is supposed to be L di dt. So Vs, this is supposed to be L di dt. And you also know that VR is supposed to be I of R. So if you're able to understand that, then dividing throughout by R, you divide throughout by area. We shall have, this becomes to I. It's supposed to be L over R di dt plus I. Now collecting like terms together, we shall have I minus I. It's supposed to be L over R di dt. And from there, you're supposed to separate the variables, and separate the variables, make L and R be separately, then you shall have R over L dt is equals to di over I minus I. So by integrating both sides, we now integrate both sides with respect to the variable. So by integrating both sides, we shall have R over LT plus a constant is supposed to be Ln of I minus I. So from here we replace the initial value of the constant at the start of the charge. At the start of the charging, i.e., when the switch is closed, T is supposed to be 0. T is supposed to be 0, and this at the time is supposed to be 0. And whatever we shall have as transient current is supposed to be also 0. Then we shall be able to factor in to place the K value. So T, so this is R over L. T is 0, so multiply by 0 plus K. Supposed to be minus Ln of I minus 0. So K is supposed to be minus Ln of I. Replace K then in the expression above, Therefore, R over LT minus ln of I is supposed to be minus ln of I minus I. We collect like terms together, then we shall have R over LT is supposed to be minus ln I minus I plus ln of I. When we divide this throughout, then we shall have, if I divide throughout with a minus so that we can be able to collect the like terms together, then we shall have minus RL of t. It's supposed to be ln of I minus ln of I. By using the law of logarithmic ratios, we can now write this minus R over LT is supposed to be ln into I minus I over I. So we are supposed to get the natural logs of both sides. We're supposed to get the natural logs of both sides. And natural logs of both sides means that natural logs of both sides, in this other end we shall have E minus R over LT is supposed to be I minus I over I. Then shall have the crossing that I, E minus R over LT is supposed to be I minus I. Then collect the like terms together. I means that I into 1 minus E minus R over LT. So we're supposed to be sketching this so that you understand how the graph is drawn. So when t is equals to 0, when we sketch this, t, and this is the I. When t is supposed to be 0, then we shall be having the value being equals to at this point here. When t is 0, then whatever you have here is 1, and shall have 1 minus 1 shall have the 0. Then when t is infinity, we shall have the current here, I is supposed to be I. And shall have the line there drawn this way, and shall have this thing as charging. The voltage across the resistor VR is given by IR, and I is supposed to be VR is supposed to be I of R, and that means that we shall have R multiplied by VR. I is supposed to be multiplied by I into 1 minus E minus R over LT. This means that VR is supposed to be VS into 1 minus E minus R over LT. So we also sketch that graph. This is supposed to be T, this is supposed to be V of R. So when T is supposed to be 0, then we shall have V of R equals to V of S here. We shall have sketch this. and shall have, so this is VR is supposed to be Vs into 1 minus E minus R over L T. The voltage across the inductor VL is given by VL is supposed to be Vs minus V or R, and this is Vs minus VR is given by Vs into 1 minus E minus R over L T. We open the brackets, this is Vs minus Vs plus Vs into E minus R over L T. So this and this cancelled, then we have VL being given by Vs E minus R over L T. So similarly, VL can be given by VL supposed to be L di dt, but I is supposed to be given by I minus I into 1 minus E minus R over L T. Replacing that in the equation, shall L d dt of I into 1 minus E minus R over L T. Then you shall have L I. Differentiate that, shall have minus E minus R over L T dot R dot minus R over L. And this cancels. Minus and minus becomes a positive. Then we shall have that as I R E minus R over L T. And this gives us Vs E minus R over L T as V of L. Then from there, you're supposed to sketch the graph. So when you're sketching this graph, the graph sketched as follows. Then we shall have that. Whatever I have is VL. VL, whatever I have VL, when t is equals to 0, when t is equals to 0, then you have the VL being equals to Vs. So this VL is equals to Vs. Then when t is infinity, then we have get the 0. So we shall have the graph appearing this way. So this is VL is supposed to Vs E minus R over L T. Is given by L over R. when the inductor is connected to the load or resistor to discharge, then according to Kirchhoff's voltage law, KVL, we had 0 plus 0 is equals to, not 0 plus. We have the Vs supposed to be VL plus VR, but the supply voltage is 0 then, so this is supposed to be 0, it's supposed to be VL is supposed to be L di dt plus I of R. So minus I of R supposed to be minus is L di dt. So separate the variables. So you shall have R over L dt minus is equals to di over I. Integrating both sides with respect to the variable, minus R over L t plus a constant supposed to be ln of I. Then we are supposed to replace now the initial conditions. Inserting the initial conditions. T is equals to 0 and I is equals to capital I. Insert this. Then insert that, we shall have K being equals to ln of I. We now replace the constant K in the equation. Replacing the constant K, we shall have minus R over LT plus ln of I is supposed to be given by ln of I. So minus R over L of T is supposed to give us ln of I minus R, ln of I. And this means that minus R over LT is supposed to be ln of I over I. Getting the natural logarithms, getting the natural logs of both sides, we shall have E minus R over LT is supposed to be I over I. So I is supposed to give us I, E minus R over LT. So we sketch the graph. This is T, this is supposed to give us I. So when T is supposed to be 0, then I is maximum. then I is equals to I. When t is infinity, then I is 0. Shall have the graph being, this is, so this is I is equals to I e minus r over L t. Scusa. The voltage across the resistor VR supposed to be I of R, which is supposed to be R into I is I E minus R over L T. That means that VR is supposed to be VS E minus R over L T. So we sketch that graph. This is V of R. When t goes to 0, then have this as Vs. I shall have this. The voltage across the inductor VL is supposed to be L di dt. It's supposed to be L d dt of I was given by I is I E as R over L T. We shall have is thus L I d dt. L I d dt of that we shall have minus R over L E minus R over L T. We have that L and L cancelled. We shall have minus V of S E minus R over L T is given us VL. So we are seeing that there's a minus sign, and that minus sign comes as a result of Lenz's law. That minus sign comes as a result of Lenz's law because it tends to oppose the source of the flux. The voltage in the inductor tends to oppose the source of the flux with the supply voltage. So that's we sketched then that one. This is T, this is 0, this is V of R, it's a minus. When T is 0, then VL, this VL is supposed to be VS minus. When T is infinity, that will, so we shall have this volume. So this is 0. So this is VL is also minus VS into E minus R over L T. So if this graph was to be drawn with a positive sign, then it means that we shall have the sketch coming from the upper side of the plane. If it was having a positive sign, if the way you can present the same line, the positive cycle, you shall have it moving at the positive plane, and it's going to change the sign. This is because it's minus Vs towards 0. So from here, we just do examples. So we shall have our first example. So this is the first example that we're going to have as example 1. And we look at this circuit, we have been told that we have got a relay that has got an inductance and a resistance, and the relay is connected to a circuit which is giving with a supply of 220 volts, 50 hertz. So we are being asked to time the time constant. So the first time is time constant. It's supposed to be L over R. Now L over R, we have the L, the inductance there, and we have the R. Are we there? L over R as a time constant is 0.12. R is supposed to be 18. So we shall have this as 6.67 times 10 minus 3 seconds. Roman 2, we are being asked about the steady state current. Steady state current. I is supposed to be V over R. And that one is supposed to be V given as 220 volts. Our R is 18. Gives us what? It's 12.22 amps. Roman 3 is current equal to time constant. Roman 3. Current equal to time constant. Let us remember that we connected this to a supply. That means the inductor was charging. Then I is supposed to be I into 1 minus E minus R over L T. Then I is supposed to be I is 12.22. 1 minus E. Time constant. Time equal to time constant, then we shall have that as minus 1. So we have that. Time equals time constant. Current equal to time constant, yeah. That's 12. 7.58 amps. Shall have I as 7.58 amps. 58 or 58 or 59 amps. So we're going to the last part of it, as part number 4. The time taken for the current to rise within. Time taken for the current to rise within 1% of the steady state value. So what is 1% of the steady state value? Then you shall have 99 over 100 times the steady state value was given by 12.22. 12.22. This is 12.09 amps. Therefore, I is supposed to be 12.09 amps, which is supposed to give us 12.22 into 1 minus E minus R over L minus tau over 6.67 times 10 minus 3. So we divide the two. 12.09 over 12.22 minus 1 is supposed to give us minus E minus T over 6.67 times 10 minus 3. Then you divide this and subtract 1. Minus 0.01, supposed to be minus E minus T over 6.67 times 10 minus 3. So we get the ln of both sides. Ln of answer. Minus and minus will cancel. This minus 4.605 supposed to be minus T over 6.67 times 10 minus 3. The minus cancel, then we shall have our T be equals to 4.605 times 6.67 times 10 power minus 3. So T is supposed to give us 4.605 times 6.67. This is 0.03 seconds.